Good afternoon. We're back again, and we're on March 25th's lecture, and we're still on section 10.5, and I'm going to go over the problem that I assigned with you before. It is a rational function, and the first thing we wanted to find is all asymptotes. So if we look at the vertical asymptotes, we set the denominator equal to 0. Notice what I did here. I took this and I expanded it out, and that does two things for me. It makes it easier to find the horizontal asymptotes, and it also takes away the fact that I would have to do the chain rule here. This becomes a simple sequential power rule. So let's solve this just by factoring it. So we get an x here and an x here. 1 times 1 is 1. And we have a plus 2, so we just do like that. And what we get here, actually the same answer. In case you want to know, mathematically, this is called a degenerate solution. You have the same solution for both roots, and it means there's only one root here. So we're just interested in x equal minus 1, and this is your vertical asymptote. So x equal minus 1 becomes your vertical asymptote. Now, as far as the horizontal asymptotes, we have to examine the powers of n and m, and here n is the one in the numerator, which is 2, and m is the one in the denominator, which is also 2. See, if I didn't expand it out, I would have trouble figuring out what that was. So now we have n equals m, which if we look up from our rules, we have that the horizontal asymptote, y, is equal to the coefficient in front of the first term in the denominator and the coefficient in front of the second term in the numerator divided by each other. So it's 1 divided by 1. So 1 is your horizontal asymptote. So here we have two asymptotes. We have the vertical asymptote x equal minus 1 and the horizontal asymptote being 1. Later on, when we graph this, we'll see how this plays out. The second part of this asks for, and I'm on page 10.57 on your notes. It says find any points of maximum or minimum. So the first thing we have to do is find the critical points. And in order to do that, like we know before, we have to take the first derivative and set it equal to 0. So the first derivative here, f prime x, is going to be using the quotient rule, which is the bottom. Well, let's put it down here. Let's let u equals x squared and v equals x squared plus 2x plus 1. So it's the bottom, x squared plus 2x plus 1, times the derivative of the top, which is x squared, minus, and remember we put a bracket here, so remember to distribute that negative sign, minus the top, which is x squared, times the derivative of the bottom. And don't forget, which everybody does forget, close the bracket, to divide this by the bottom squared, which is going to be v squared, which is going to be x squared plus 2x plus 1 squared. Now notice I did this a little bit different in your notes. I actually used a chain rule. So I'm changing it around a bit. You can do what's in your notes. We will get the same solution, but I'm giving you an alternative. So let's go and let's take the derivatives and figure out what the first derivative will be. And I'm going to leave the bottom on here and erase the rest of it. All right, so we want to complete the derivative here. F prime x, you stand up for this. It's going to be x squared plus 2x plus 1. The derivative of x squared is 2x. I'm going to subtract that, bracket. You have x squared. And this is going to be, the derivative of x squared would be 2x plus 2, and the derivative of the constant would be 0, so that's all we have. And x squared plus 2x plus 1 squared. So now I'm going to distribute the 2x across this. So I'm going to get 2x to the third plus 2x plus 4x squared plus 2x minus, now I'm going to distribute the x squared across this. It's going to be 2x third plus 2x squared, and that's going to be all over x squared plus 2x plus 1 squared.
Dr. Mirabile, don't you have a minus sign here?
Yes, I forgot to distribute. Oh, no, what I want to do is here.
Yep.
No, that's what I want to do. Well, what I forgot to do is keep the bracket. Okay. So now all we have to do is remove the bracket. That's going to be 2x third plus 4x squared plus 2x minus 2x third and minus 2x squared over this now notice this cancels nicely, and the 4x squared and the minus 2x squared sort of go together nicely. So what do we have when we finish this? Let's see, we have 4x squared minus 2x squared, which is 2x squared plus 2x over x squared plus 2x plus 1 squared. Well, that gives us the, notice it's a little bit different than when you got in your, for the other thing, but it should give us the same thing. What I'm going to do is check over my math a little bit, but I'm pretty sure that everything really came out well. I took the first one times the derivative of the second, which is x squared, minus the top times the derivative of the bottom, which was x squared plus 2x plus 1, which would be 2x plus 2. And when I multiplied that out, I got 2x third plus 2x squared, which is correct. And when I subtracted 2x third, distributed that, 2x third plus 4x plus 2x, so we get 2x third minus 2x third, 4x squared minus 2x squared, and then 2x. So this gives me a little bit different derivative than the other one. Does anybody know why? Well, let's go on and see what we get for this. Okay, let's see what we get for this, because this tells us something. If I can find my eraser. And I'm sort of glad I did this like this because it introduces a concept that the other one ignores. Okay, let's set f prime x equals 0 to find the critical point. So where we get 2x squared plus 2x over x squared plus 2x plus 1 equals 0. Now, if I multiply both sides by x squared plus 2x plus 1, squared, sorry, doesn't make a difference because it's going to
go away.
Cancel out anyway. And I'm going to do x squared plus 2x plus 1 squared times 0. Anything times 0 is 0. So what we get here is these cancel. That's 0. I get 2x squared plus 2x equals 0. Now what I want to do is factor out the x. So let me factor out a 2x, and that gives me x plus 1 equals 0. Okay? So now if I take my thing here, I'll have 2x equals 0, so that x equals 0 is one of my solutions. And then I have x plus 1, so that x equal minus 1 is another one of my solutions. Sorry, let me make that. It's tough to read and it's bored a little bit. So I have two solutions here. X equals 0, x equal minus 1. They're critical points. I still haven't tested whether they're positive or negative, but let's use this as a teaching moment to figure out what's wrong with the x equal minus 1. So let's put the solutions on here. The critical points was x equals 0 and x equals minus 1. Well, let's go back to the original problem, the way it was written. F of x is x squared over x plus 1 squared. Now let's substitute these two solutions in there. F of 0 is going to be 0 over 0 plus 1 squared, so that's going to be 0. That's okay. That's a real solution. But what if I do f of minus 1? Look what happens. Minus 1 plus 1 squared is x squared. Is minus 1 squared or 1? And this does not exist. So notice that's also a point of vertical asymptote. So therefore, this is not a solution. That cannot be a critical point. So when I did this just using the chain rule, all that came out on the notes was x equals 0. But when I did it this way, I got two solutions, but one is really not a solution because it gives us a value that doesn't exist. So I only have one critical point, x equals 0, and we will test that in a minute.